So let's discuss some of the probable questions that you may get in the examination from this chapter. From the short question answers section, that is for 2 marks, you can get some questions like this, like state Simpsons rule, state trapezoidal rule, state the difference between trapezoidal rule and Simpsons rule, and numericals. Numericals are very important from this chapter, and you are very likely to get some of the numericals from computation of area by following certain rules. So let's have a look at this numerical. So the question says, the following offsets were taken from a chain line to an irregular boundary line at an interval of 10 meter. Okay, so the interval is given 10 meters, so the chain is 10 meter. 10 meter chain is given here, and the offsets are given as, the offsets are nothing but the ordinates 0, 2.5, 3.5, 5.0, 4.6, 3.2, 0 meter. So these are the ordinates given. Let's count the number of ordinates: 1, 2, 3, 4, 5, 6, 7. So odd number of ordinates are given, so we can directly apply the Simpsons rule, as we have already studied that Simpsons rule has got its limitation that it can be only applied to odd number of ordinates. So since in this question odd number of ordinates are given, so we can directly apply Simpsons rule. So next the question says, compute the area between the chain line and irregular boundary line and end of the offset by following mid-ordinate rule, trapezoidal rule and Simpsons rule. Okay, by following these 3 rules we have to calculate the areas between the chain line and the irregular boundary line and the end of the offset. Okay, fine. So let's see how we can approach this numerical. So first we have to draw a figure. So see, 10 meter of chainage was given. So 10 meter of chainage, and offsets were given as 2.5, 0, 2.5, 3.5, 5, 4.6, 3.2 and 0 again. So how can we get the area by following mid-ordinate rule? So first we have to calculate the mid-ordinates: h1, h2, h3, h4, h5 and h6. So how can we get h1? By taking the average of first 2 ordinates. So 0 plus 2.5 divided by 2 equals to 1.25 meter. So in the similar manner we can get other mid ordinates up to h6, and the required area is then calculated by multiplying the regular interval with the sum of all the mid ordinates. See, here the regular interval is 10 meters, so 10 whole into 1.25 plus 3 plus 4.25 plus 4.8 plus 3.9 plus 1.6 equals to okay, here there is a computational error. The 4.8 ordinate has been missing over here. Don't worry, I will calculate it. So 10 whole into 1.25 plus 3 plus 4.25 plus 4.8 plus 3.9 plus 1.6, which is equals to 18.8. okay, this value is correct, but here while adding up 4.8 is missing. So 10 into 18.8 equals to 188 meters square. While approaching the numericals, it is very important that you should mention the units properly. Okay, so if you forget to mention the unit, then there are chances that you might lose your marks in examination. Okay, so be careful for that. Then next one, the question said to find out the area by following trapezoidal rule. So in trapezoidal rule, the required area, by following trapezoidal rule, we can get the required area by taking the sum of first ordinate and last ordinate plus 2 times the remaining ordinates or intermediate ordinates multiplied with half of the common distance. So here the common distance is 10 meter. So 10 divided by 2 whole into sum of first ordinate and last ordinate, which first ordinate is 0, second ordinate is, first ordinate and last ordinate is also 0. So 0 plus 0 plus twice the sum of the remaining ordinates or intermediate ordinates. So 2 whole into, what are the intermediate ordinates? 2.5, 3.5, 5, then 4.6, then 3.2. So we can get, we can calculate 2 into 2.5 plus 3.5 plus 5 plus 4.6 plus 3.2, which is 37.6. So 37.6 multiplied with 5 equals to 188 meters square. And then Simpsons rule. So how can we get the area by following Simpsons rule? By taking the sum of first ordinate, last ordinate plus 4 times the even number of ordinates plus twice the odd number of ordinates multiplied with 1/3 of common distance. So the common distance is here 10 meter. So 10 divided by 3 whole into first ordinate plus last ordinate plus 4 times sum of even number of ordinates here. Look at this figure. It is the sum of first ordinate, last ordinate, which is 0 plus 0 plus 4 times even number of ordinates. So these are all the intermediate ordinates, and we have to multiply 4 with the even number of ordinates. It is the second ordinate which is even, so 4 whole into 2.5. 3.5 is odd ordinate, so we are going to neglect it here. So next even ordinate is 5, so 2.5 plus 5. 4.6 is odd number of ordinates, so we are going to neglect this. And next we are going to take 3.2. So 4 whole into 2.5 plus 5 plus 3.2 plus 2 whole into odd number of intermediate ordinates. So here 3.5 and 4.6. So we have taken this, and if we calculate this, we are going to get 196.66 meters square. So in this manner we are going to calculate the area between the chain line and irregular boundary line and ends of the offset. So thank you very much, students. So, as this is a one-way communication, so if you are having any doubts, you can drop your doubts in the comment section below, or you can post your doubts in the official WhatsApp group. Thank you very much.